On to 15. C equals 5/9 F minus 32. The equation above shows how a temperature F measured in degrees Fahrenheit relates to a temperature C measured in degrees Celsius. Based on the equation, which of the following must be true? 1. A temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. Number 2. A temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. And number 3, a temperature increase of 5/9 degrees Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. First thing, I say this a lot, look at your options. Their options are 1 only, 2 only, 3 only, or 1 and 2 only. All right, so there's not any sort of thing where we can say, oh, if we can eliminate this one, we can eliminate 3 options. Not as helpful as we'd like, but, just keep this in mind. It's either 1 or 2 or 3 or 1 and 2. Now, there's a couple ways to do this. Again, this is a timed test. Time is of the essence. You want to be as quick as possible. For this particular one, I honestly think the best way to do it is to think of it logically without doing the math of multiplying things through. You can if you want, but especially because you don't have a calculator. If you're multiplying something by 5/9 or 9/5, no one wants to be doing that, right? So, what do you know about Celsius versus Fahrenheit? Well, what is freezing in Celsius? It's 0. And boiling is 100. In Fahrenheit, freezing is 32. And boiling is 212. So if you're viewing this as linear equations, lines, which they are, because they are increasing at a steady rate, both of them, it's the same rate each time, so that is linear. Celsius, this is a gap. There's 100 degrees in here. In Fahrenheit, there's 180 degrees in here. So what does that tell you? If you're thinking about how they increase, is that Celsius is increasing more slowly than Fahrenheit. It's just going like put, and Fahrenheit's going, whoop, it's increasing much more rapidly. So C is increasing more slowly, and Fahrenheit is increasing more rapidly. Well, what are our 3 options here? A temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 of a degree of Celsius. That seems like that might be logical, right? Fahrenheit's increasing by 1 whole degree. Celsius is increasing by only 5/9. So okay, that's a possibility. Number 2, a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees in Fahrenheit. Well, is that saying the same thing as number 2? It's saying again that if the Celsius is increasing by just a little, then the Fahrenheit is increasing by more. Well, let's just see. I'm actually not even going to look at this up here. I just want to look at these 2 here. So 1 degree of Fahrenheit is equal to 5/9 degrees of Celsius. That's what the first one said. And the next one said 1 degree of Celsius is equal to 1.8 degrees of Fahrenheit. Okay, now when I look at this, I want everything to kind of be the same. So I want this to be fractions, because I got a 1.8 and I got a 5/9. Well, what is 1.8 in a fraction form? This is the same as, I'm going to write it, I'm going to slide things up a little bit, 1 8/10, which would be the same as 1 4/5. And if I converted it to a fraction like this, you would say 5 times 1 plus 4 gives me 9/9/5. All right, so now it's saying that 9/5 degree of Fahrenheit is equal to 1 degree Celsius. All right, so how would I get from this to see if these are equivalent? Well, here I have 1 Fahrenheit and I want to get to 9/5. I need to multiply this 1 by 9/5. So if I multiply both sides here by 9/5, what happens? On the left, I get 9/5 F, or Fahrenheit. Here, 5/9 times 9/5. Those fractions cancel out, and I am just left with 1 Celsius. So this is the same. 1 and 2 are saying the same exact thing. So, it's starting to look like D is our best option, 1 and 2 only. Well, let's look at number 3, because Like, well, what if I'm reading this wrong and maybe 1 and 2 are both wrong? They're saying the exact same thing. So either they're both right or they're both wrong. Let's look at number 3. A temperature increase of 5/9 of degree of Fahrenheit is equivalent to a temperature increase of 1 degree in Celsius. So that is saying that Celsius is moving up faster than Fahrenheit. Well, that's not true. Fahrenheit is moving up faster than Celsius. So it's saying part of a degree Fahrenheit, Celsius goes up a whole degree. That's obviously wrong. So 3 is out. 1 and 2 are both saying the same thing. They're both true. 1 and 2 only. Now I'm kind of overlooking the other thing that you might know. If you've worked with Celsius and Fahrenheit in your math class and you know this 5/9, 9/5, the 1.8, this may look very familiar and you may not have even needed to kind of prove this by going through this conversion to try to make sure that 1 and 2 are both saying the same thing. Yeah, if that's the case, that's great. That's great. But, not everyone remembers everything, because a lot of times, we have a lot of stuff we have to learn before these tests, and, things can be forgotten quite easily. It happens to all of us. So this is sort of a quicker, I think, logic-based approach. The other way you can do this, I think it takes more time, again, because you don't have a calculator, but you can absolutely plug in numbers up here and see what happens. So like if you plugged in, you started at 0 degrees Fahrenheit and you did this math, which actually, I don't think I would. I think I'd start at 32, so these would cancel out. That's what I would put 32 in there and, cancel out. And, just for giggles, I'll show you what happens there. If you do that, if you do this the long way. And again, this is dependent on you realizing that 32 is the best choice to plug in. If you put in other numbers, you're going to be in for a lot of painful multiplication. And I'm sorry. So let's say here, it says a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 of degree Celsius. All right, so let's say I'm going in Fahrenheit from 32 to 33 degrees. What happens if I put in 32? 32 minus 32 times 5/9. 32 minus 32 is 0. 0 times 5/9 is 0. So when Fahrenheit is 32, Celsius is 0. Which again, if you have those freezing and boiling points, you would have that in your brain, but that shows you the math of it. All right, so Celsius is 0. What happens when Fahrenheit goes up to 33? 33 minus 32 times 5/9. 33 minus 32 is 1. 1 times 5/9 is 5/9. So in Fahrenheit, we have 33 degrees Fahrenheit. We have 5/9 of a degree Celsius. So that proves number 1 is correct, that is accurate. At which point you could do what I showed you, where you try to see if number 2 is saying the same thing as number 1, which it is. You would know 1 and 2 only. The other way would be to put numbers in here again. Temperature increase of 1 degree Celsius. So you might start with what you already had, where when Celsius is 0, Fahrenheit is 32. So you go, okay. And let's bump Celsius up to 1 times 5/9 times F minus 32. And you would need to multiply by 9/5 on both sides. You get 9/5 on the left. All right, this 9/5 cancels out with 5/9, leaving F minus 32. And then you would add 32 to both sides. So Fahrenheit is equals 32 plus 9/5. Then you would need to convert 9/5 to a fraction or to a decimal and say that's 1.8. That's going to be 32 plus 1.8. And you go, oh, a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. Yeah, again, see, as soon as you get those fractions in there like that, I think it's a recipe for errors to creep in when you are doing this without a calculator and you're doing things quickly because, you're trying to speed along. So again, said it before, say it again. I think just looking at this logically about what you know about the Celsius and Fahrenheit scales, if you're not remembering, the relationship offhand, I think it's probably the best way to approach this problem.
If this was helpful or useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.